In this class, we're going to learn how to differentiate a parametric equation. Okay, let's start with the first question. Given that y equals to cos t and x equals to sin t, find dy dx. Okay, given that y, okay, the first question now, y equals to cos t and x equals to sin t, we are asked to find dy dx. Now, how do we solve for dy dx? Now, in our previous class, I told you that if you are asked to differentiate a parametric equation, you are going to differentiate the two equations with respect to the variable that you are given. Now, the variable that is present in both equations, the variable that is connecting both equations is t. You understand? So we are differentiating y and x with respect to t. Okay, let's progress. For this, we are going to have y equals to cos t. Here, dy all over dt will be equals to. Now, don't forget, in our previous class, we've learned how to find the derivative of a trigonometric function. If you differentiate sin x, please listen. If you differentiate sin x, the derivative of sin x will give us cos x, okay? And if you differentiate cos x, the derivative of cos x will give us minus sin x. Now, pay attention. We have cos t. We want to differentiate cos t. What will be the derivative of cos t? The derivative of cos t will be minus sin t. You understand? So, the derivative will be minus sin t. Now, we have x equals to sin t. If x equals to sin t, the derivative of x with respect to t will be equals to what? Now, since we know that if you differentiate sin x, you're going to get cos x. Hence, if you differentiate sin t as well, you're going to get cos t. So, the derivative of x with respect to t will be cos t, okay? So, here I'm going to have cos t. Now, having done that, we can now progress to use the parametric equation formula that I gave you in our first class. Don't forget, I told you dy all over dx is equals to dy all over dt multiplied by dt all over dx, okay? Now, in the above equation, we have already found the derivative of dy dt, but we don't know dt dx, but we know dx dt. Hello, we don't know dt dx now, right? But we know dx dt. I told you in our previous class that dt all over dx is the inverse, the reciprocal of dx over dt, okay? The reciprocal of dx over dt will give us dt dx. So now, with respect to what we have here, you can progress like this. Dy all over dx is equals to dt dx. Dy dt is minus sin t. So I'm going to have minus sin t multiplied by dt over dx. Dt over dx is what? 1 over dx dt. So I'm going to have 1 over dx dt is what? Cos t. So I'm going to have 1 over cos t. Hence, the derivative of y with respect to x will be equals to minus sin t multiplied by 1. That is what? Minus sin t all over, minus sin t all over cos t, okay? Now, don't forget, from the basic trigonometry, sin x over cos x will give us tan x. Hope you know. Sin x, the quotient of sin x over cos x will give us tan x. Okay? So here we have sin t over cos t. We have minus sin t over cos t. So here I'm going to have dy over dx will be equals to minus tan x. You understand? Because listen, the reason why I have minus tan x is because sin x, is minus tan t. Minus tan t. The reason why I have minus tan t is because, you know, sin x over cos x from basic trigonometry is what? Tan x. You understand? So now we are having minus sin t all over cos t. So this will be equals to minus, this minus sin t over cos t is what? Tan t. Okay? Just like if sin x over cos x is tan x, sin t over cos t is also what? Tan t. Okay? So, but this negative sign is going to be present. Do you understand? Okay, so that is the solution to that question number 1. I'm very sure you understand the solution. Okay, if you didn't understand, let me know in the comment section. Now, let us progress to question number 2. Please, I want you to pay attention. Given that y equals to cos 2t and x equals to sin t, find dy dx. Given that y Question 2 here, y equals to cos 2t. Cos 2t and x equals to sine t. We have to find dy over dx. Well, you can try this question by yourself. To write the question, when you are done, drop your answer in the comment section, okay? Before you go, don't forget to hit the like button and subscribe to the channel. So that will be all for this class. See you in the next class. I'm going to provide solution to that question in our next class, okay? So don't worry yourself. I just wanted to try it and drop your answer in the comment section, okay?